Hello, in this presentation I will present my work on titulated copper iron tin sulfide thin films of solar cells, prepared at Laboratory of Materials, Energy and Environment of Faculty of Science Semlalia, Marrakech, which whose outline is. Firstly, I will start from a problematic of work. Secondly, I will present the experimental section concerned the preparation of CFTS thin films and CFTS-based solar cells. After that, I will present the part of results and discussions. Finally, I will end with conclusions. The solar cells of second generation commercialized are based of absorbers CIS, CIGS, CDTE, but those absorbers suffer some limitations such as toxicity of cadmium and selenium, non-abundance of indium and gallium, and high cost of materials. Therefore, the necessity to develop other absorber solar cells materials which are low cost and environmental friendly, such as CFTS thin films with ideal formula chemistry, copper, iron, tin sulfide, object of this work. Firstly, I will present the part of experimental section concerned to synthesis of CFTS thin film solar cells by surgical spin coating technique. The precursors is to prepare the surgical solution where copper chloride, iron chloride, tin chloride, and urea dissolved in solution of methoxyethanol and deionized water. The solution was stirred on hot plate at 50 degrees C for 20 minutes. The bronze surgical solution was formed. After that, spin coater was used to deposit the CFTS thin films on cleaned soda lime glass and on fluorine tin oxide glass substrate. Then the obtained thin film was dried in air at 200 degrees C for 20 minutes to remove the residual organic materials. After that, the synthesized thin film was annealed at 400 degrees C for 40 minutes in nitrogen atmosphere using tubular funnels. Subsequently, the synthesized thin film were analyzed by X-ray diffraction, Raman spectroscopy, scanning electron microscopy, energy dispersive X-ray spectroscopy, and UV visible near infrared. Secondly, I will present the part of experimental section concerned preparation of CFTS-based solar cells. The structure of device is firstly 80 nanometers thick of intrinsic zinc oxide thin film has been deposited by surgical method on the cleaned fluorine tin oxide substrate. Then 50 nanometers thick of cadmium sulfide thin film was deposited by surgical method. After that, the copper iron tin sulfide thin film was deposited on the top of cadmium sulfide thin film. Finally, opaque contact of orium was deposited on the surface of copper iron tin sulfide thin film by sputter coater. The fabricated solar cell has been characterized by solar simulator. For results and discussions, X-ray diffraction analysis confirmed the formation of CFTS tetragonal stony structure according to standard reference cards, and no other sulfide component observed. In addition, the lattice constant and the crystalline size have been calculated. The latest constant value are in good agreement with the standard value from the reference cards. The crystalline size is found to be 60 nanometers. Also, Raman spectroscopy confirmed the formation of standard CFTS in films. For morphology and elemental composition analysis, the surface morphology of prepared CFTS in film has uniform and compact. The energy dispersive spectroscopy confirmed the presence of copper, iron, tin, sulfide elements, and with stoichiometry. Also, the optical characterization has been performed. It's shown from this figure the transmittance is less than 25% in the visible region, and the fundamental absorption age has been clearly observed at 824 nanometers. In addition, the band gap of the prepared CFTS in films is about 1.5 electron volts. The analysis of fabricated solar cells showed a photovoltaic activity with efficiency of 4.7%, open circuit voltage of 0.8 volt, and the fire factor of 50%. Finally, the conclusions of our work are: copper, iron, tin sulfide absorbed in film was successfully deposited by a facile salt gel method without sulfurization process. The analysis results indicate that a per-standard polycrystalline structure has been formed with a uniform and compact surface. The best CFTS-based solar cell showed a high open circuit voltage of 0.8 volt and a conversion efficiency of 4.7%. Thank you for your attention.